Hello and welcome. My name is Ryan. I'm also known as RM2K Dev. Guys, it's been a while since I made a video. I'm back today to share with you a product. First of all, this is not a sponsored video. This is just something I felt like doing. So obviously I've got, 3D printers and a little bit of a retro game collection, and I'm a bit of an electronics enthusiast. Something I've always been interested in using and having, and, obviously, I guess, having for diagnostic purposes and electrical engineering purposes and playing with, electronics and Arduinos and all of that good stuff is a digital oscilloscope. And so I had a look at the market, and obviously there are lots of brands and they can become very expensive very quickly. But I found this one on AliExpress. It was very cheap. I'll leave a link in the description, and I'll put a price on the screen now. Much cheaper than a reliable professional tool. So this is probably not that. I've heard that they are a respectable brand and that they've been around for a long time. And so I thought I'd give it a try. And that is the Hantek digital storage oscilloscope. This is the 100 megahertz, 1 gigasample digital storage oscilloscope. 2 channels, as you can see here. We've got channel 1, channel 2. They use standard BNC type connectors. It came with 2 probes, which are actually quite nice probes. I'll just hold that up here. They've got the adjustable calibration point on the top here. And I'm not going to go through the whole unboxing procedure. I mean, if you want to look at someone open this from a box, feel free to, just have a look on YouTube. There are some people who've unboxed these. I will say the package was fine. It arrived pretty quickly. It was well protected in its packaging when it arrived. The only issue that I did have when it arrived was the screen protector, which I'm just kind of pointing at the screen now. The pull tab to take the screen protector off was actually embedded underneath the plastic along the side of the oscilloscope. So it was very hard to get that off. The way that I had to do it was actually just kind of scratch the screen protector so that I could wedge a piece of plastic underneath it and then pull back to get it off the screen, which could have left a scratch on the screen, but thankfully in my case it didn't. So main reason I'm making this video is because I was looking at reviews for this before I purchased, and I couldn't really find a great detailed explanation of all of the features that it had. Now the AliExpress listing and the website and all of that, it goes over some of the features, but I really wanted to see someone just go through the menus and show me what it could do. And so that's what we're going to do today. So first of all, I've got this set into the black theme. So if I just go through the menus here, you'll see I've got it set to black. I hope you can see that. Yes, you can. Now, I don't know why it's appearing as blue on your screen. You can see this all blue here, but from my vision, this is a really nice black theme. Not a blue theme, it's a black theme. I'm looking at a black oscilloscope here. So I'm not sure why it's appearing as blue, but the blue that you're seeing in the camera right now is actually the color that the default theme is. So if I change the color of the theme to green, which is horrible, and to pink, which looks blue on your screen, and to yellow, and to blue, this is the blue that it comes as by default. Now, I will be completely honest with you guys here. You can't see the color of this blue in my camera, and none of the reviews that I found online were able to show the color of the theme, but you're just going to have to trust me. The blue is very vibrant. It's not washed out at all. The screen is sharp. You can see pixels, it's not a retina type display, but it is a native resolution. It's not like when you're looking at, a Nintendo Switch and it's blurry and, you can see giant pixels everywhere. So it is a very good screen. I'm just going to change that back to black, and for you guys, it's appearing as a bit of a bluey kind of gray. But as I said, on my end over here, it is a really nice black. So yeah, you've got the option to change the language. It supports, this is something I couldn't find online, but it's got English, it's got Chinese, it's got different type of Chinese, it's got Japanese, French, I'm assuming that's Russian, Dutch, Spanish, Korean, Portuguese, and back to English. So you do have language adjustment. You can make it so that when you press a button, it will beep. So if I just change the thing, you've got the little horrible beeps there. I'm going to keep that off. Going to the second page here, it's got pass-fail testing. It's got data recording to USB. Apparently, you can connect it to a printer and just through USB, and it will print. I haven't tested this. It does have some options, for video options and the waveform options and all these different types of options here. So I'm just going to back out of that. So yeah, that's our utilities menu. So the layout is very standard. It's a standard oscilloscope kind of layout. Across here, you've got your channel 1. So this kind of lines up. So you've got channel 1 here, and you've got channel 2 there, and between them you have math. Now, if I just open up the channel 1 menu, I can show you what you've got. You've got your AC/DC ground coupling modes. You've got a 20 megahertz bandwidth limit, volts per division, coarse and fine. I'm assuming this is just changing the resolution of the sampling rate in here to render this onto the screen. You've got a probe multiplier. Obviously, I've got that set to 10 times, as I'm using 10 times on the probe right now, which is what gets you your accuracy over larger voltages. I think and frequencies. The 1 times probe, I think, can only go to like 5 megahertz or something like that. And something quite nice, you've got this option here to invert the incoming signal, waveform, whatever you want to call it, which if you're just doing some analysis of a digital line and you want to invert it so that you can use the math functions to add and subtract and divide from the second channel, then you can invert the waveform. So yeah, you've got this, like I say, you've got this invert here. You can do the same thing on channel 2. You can invert the signals over here, and then you can do math between them. Now, the thing that I was most interested in was what mathematic operations can this scope do? So you have channel 1 plus channel 2, you have channel 1 minus channel 2 minus channel 1, channel 1 times channel 2, channel 1 divided by channel 2 divided by channel 1, and then you have an FFT mode, which has all of the window modes. You've got Hanning, flat top, rectangular, Bartlett, and Blackman. And what's quite nice is when you change these, you get a little message across the bottom that tells you, if you're not familiar with FFT windows, it tells you what the window is best suited for. So if I go into rectangular, it says that this is more suitable for transient analysis. If I go to Hanning, it tells you that it's more suitable for frequency analysis. Flat top is more suitable for amplitude analysis, and you can select which channel you're going to be doing the FFT calculation on, so channel 1 or channel 2. Now, you can't do FFT on both channels at the same time, so you can only choose to do one. So that's a limitation of this scope. So for instance, you can't, and this is calculated FFT, by the way. I don't believe it's a hardware solution here. It's just software calculating from the input signal. But yeah, you can only do it to one of them at a time. So that is a limitation there. But for my purposes at home, it is more than enough. You have a second page here which adjusts your FFT zoom and whether or not you want to base this on voltage RMS or decibel RMS. And so that's the math menu. We can get out of that and go back to our channel 1. Channel 2 is now enabled because we were in the math mode and that turned that on. So that's fine. People have complained about the knobs. I'm pretty comfortable with these. You turn right, it goes up. You turn left, it goes down. I do believe it's inverted for the second channel. So yeah, no, it's exactly the same. So if I turn right here, channel 1 goes up. If I turn right here, channel 2 goes up. If I turn left, channel 1 goes down. If I turn left, channel 2 goes down. So the knobs on mine are not inverted, as some reviewers have said. So maybe this has been fixed. It's a hardware problem that they've addressed now. These are also clicky, so you click them and it will reset everything back to 0. So this is just position offset for the signal. So moving on from here, let's talk about these probes. So obviously the probes that it comes with are not calibrated out of the factory. I don't think any oscilloscopes probes come pre-calibrated. One thing this doesn't have is sensing, so there's no sensing input here. You can't get a sensing probe and plug it into this. So when you adjust between, 1 times using this little switch here and 10 times, the probe is not going to tell the oscilloscope that your probe is in a different multiplier. So you do have to go into your channel menu and make sure that your probe and your oscilloscope are both at the same multiplication factor, otherwise you're going to have a bad time. So I'm just going to plug this in and push that in there and twist that on there like that. So I've got my probe connected here. I'm not going to go into any, I'm not going to use this, on camera and do any testing or anything, but I will connect it up to the 5 volt 1 kilohertz test calibration signal that's built into this. It's got a little frequency generator that generates you a 1 kilohertz square wave so that you can calibrate your probes. Now currently I've got it paused. That's what this red light is telling me, run stop. So if I press this, okay, so I've connected the probe up to the 1 kilohertz 5 volt test signal, and you can see I've already calibrated this. It does come with a little pack of accessories. You can change the little colored rings to match the channels and the 2 little screwdrivers, and you can just insert the screwdriver into the probe, and then you can adjust the compensation, the probe compensation here. So out of calibration, you just bring it into calibration just by squaring that up like that. Quite simple, really, and that probe is now calibrated. So you can go into our trigger menu, for instance. So let's go over here, go into the trigger menu. You can trigger on edge video signals. So it can do PAL and CCAM. It can do odd and even field. So if you're working with analog video, like in old retro game consoles, you can troubleshoot your video signals. We've got pulse triggering, slope triggering. You can time-base overtime triggering and alternate mode triggering. I don't know what this does, to be honest. I'm assuming it's just a different mode, but I don't really know, so I'm not going to claim to know what that is. You can trigger on rising and falling edge of a signal here, which is nice, and you can change your DC, so you can change your coupling from DC AC. You can use noise rejection, high frequency, and low frequency rejection. So there's a bunch of different trigger modes in here, and when you're in the trigger menu, you can use the trigger knob to adjust, at what point is the oscilloscope going to, at what voltage are we looking for a trigger here. So you can just bring that up, make sure that it intersects with the rising edge, because I've got this set to, rising slope, as this oscilloscope calls it. And we will be locked onto the signal on the rising edge. So we've got, the ability to adjust our trigger here. And obviously this is a 5 volt signal. So if this, wasn't in the middle of the voltage range here, you've got a button to set to 50%, which will automatically measure the incoming signal and voltage and set the trigger to 50% of what the voltage is. In this case, it's set it to 2.56. I'm assuming there's a little bit of inaccuracy in that, but we're right bang smack in the middle there of the waveform for the voltage that is coming in from the function generator by itself. So that's quite nice. And obviously you got this probe check stuff. You can go through and do a whole process, but as I said, there's a quicker way to do it. You just connect it up, take the little screwdriver, and then just calibrate your probes that way. Just do that, and that's pretty much how everyone does it on most oscilloscopes. You've got the option to update your firmware. We're in the system menu now, so this is utility. Page 1, system information, firmware update, save waveform. This will just save out to the USB stick. It's telling me I don't have a USB stick, so it's not going to save anywhere. You do have save and recall, which is nice. So you can set up references. So for instance, you can take a snapshot of the waveform as it is right now and save it into one of 2 different slots, which can be recalled. So this is really nice if you're trying to probe multiple areas of a PCB or some form of electronics, and you want to, you've only got 2 hands, 2 hands, assuming you have 2 hands, but yeah, the references are really nice to let you just sort of save and recall information. You've got your measurement analysis. So this is, so just doing this off of the test signal, you can see here it is picked up, this is a 1 kilohertz frequency, you know, with a 1 millisecond period, 2.56 mean average voltage, and peak to peak it's it's fluctuating 5.3 to 5.4. It shows us our minimum and maximum, our pulse width, the rise time, so it's, you know, really small times here. You can modify these as well, and you can modify them separately for channel 1 and channel 2. But you have the option to turn these off. You can have frequency period, mean voltage, peak to peak, cyclic RMS, minimum maximum voltage, rise time, fall time, that's of the leading and trailing edges here of the signal, plus and minus on the pulse width. If I go down, you've got delay, fall, duty cycle, voltage base, top, voltage mid, amplitude, overshoot, pre-shoot, mean period RMS, FOV shoot, bandwidth, frequency ref, FFR, LRR, LRF, LFR, LFT. Is there LFT at the bottom there? No, there was no LFT. I don't know what LFT is. I'm making stuff up here. But you've got plenty of different measurements. Now, again, I don't claim to know what every single one of these does. You know, I'm a hobbyist, enthusiast at home. So, you know, the stuff that's on the screen under the measure right now, you know, duty cycle is probably as complex as I need to get for working with Arduinos, you know, and basic troubleshooting and all that sort of stuff. So that's your measurements. I've shown you the save and recall stuff. I've shown you the utilities. You have the ability to do cursors, so you can do cursors based on time-based cursors. So you can adjust your start. So if I want to just position a cursor like this, then you go down and you press this button, and it's going to change. Let you adjust the end, so you can do end there, and then you've got your delta time over here, which is 495 nanoseconds. So microseconds, nanoseconds, I can't remember. Anyway, you can do your measurements like that. I'll look that up after. You can track on voltage. So again, by doing time, you're obviously going horizontal. By doing voltage, you're going vertical. And so, well, that's the wrong button. Let's reset that. You use this shared V0 to control everything. So you can adjust your voltage. So I'm just going to go from there. So that's the end point. It's like the start point. Oh, sorry, I've got both of them selected, which is nice. So you can do offsetting. So I'm just going to put that right there at 0. Then I'm going to adjust my end right there, 5.2 volts. So this is about 5 volts. And then if you press it one more time, it lets you select both of them, and you can move both of them together to calculate, you know, an offset. You know, what would -5 volts, where would -5 volts be if we were going to sort of invert that signal? For what purpose? I don't know. I'm just showing you the features, showing you some functions here. And then track, so you can do both at the same time, and you can track, you know, differences between them. So that's quite nice. So that's our cursors. We do have an acquire menu, which lets you adjust between real time and EQ time, equilateral. I don't know if that's the right word. You can click on that actually, and then you can click on help, and it will tell you. There's actually like a help function built into this, which is quite nice, you know, especially for someone like me who's, you know, like I said, not the world's best electronic engineer here, just a hobbyist at home. But yeah, you can bring up help menu, which is nice, and they've got a whole like help section built into this, which will just guide you through all of the features. But I'm going to set that back to real time. You can actually, I'll probably turn those cursors off as well, just so that it's not in the way, and then go back to our acquire menu, and then you've got, you know, averaging modes, how many samples to take. So you can take, you know, 4, 8, 16, 32, 64, 128, and 256 samples, and then average them together to get your waveform display. And then you've also got memory depth. So you can adjust your memory depth to 40K. You can go, you know, 4K is the default. It runs the oscilloscope a bit faster, so you can just work with it quickly. And if you want to capture more, then, you know, go ahead and change that to 40. Run your trigger, capture the data, save it out to USB. That's a great oscilloscope for just home use, really. I mean, I'm sure it would be fine in even a basic electronics lab, and that's kind of what I'm setting up here with this. So that's your acquire menu. You've got different modes of acquisition here. You can adjust your memory depths for when you're acquiring and your type of acquiring. Then we go into display. You can change from vectors to dots. So you can see you can see what's happening there, but I'll zoom up on one of those so you can get a bit more of a picture of what's happening there. So obviously dots is the direct samples coming in to the oscilloscope, and vectors is connect the dots basically. It does have persistency, so you can enable persistence. Now obviously this is not a perfect example of where you would want to use persistency. Let me just reset these positions here, zoom out on my horizontal axis just to get some resolution back here, and I'll move my trigger so that we're not triggered anymore, and then you'll see persistency in play here. So obviously this is not the right kind of signal that you would want to do persistence on. I'm just going to set it to infinite persistence, and you'll see it will build up, and yeah, effectively it persists the signal. So you know, if you want to use that, you can. Something else which I hadn't seen anyone mention, which is really quite interesting, is you have the mode of the oscilloscope. So right now we've got the standard mode, which is like YT, which is your regular oscilloscope mode, you know, just capturing and plotting voltage across the vertical axis and time across the horizontal axis. But you can do an XY what's the word I'm looking for? XY mode, which will use the second probe to calculate your y-axis and the first probe to calculate your x-axis, which is great if you want to do some kind of like phase analysis on an audio signal, or you know, something like that. So I didn't know that it had this mode, but this is quite useful, especially if you're working with audio. So that's quite nice. Or stereo separation type of analysis. You know, you can do all of your audio analysis on here with your left and right channels, and yeah, basically that's what that mode is there for. I didn't know it had it, so it's really quite good to know. Bring my trigger back up so that we're triggering and locking onto this signal. What else can I show you? We've got the horizontal menu here, which you can actually, if I bring up, let me just exit out of that for a second. There is a button here, I think it's F7, which will bring you up with a major and a minor window, and that's for our horizontal axis. So what you can actually do here is you can zoom in on a signal, and you can increase your time basis here, and you can look at that, and you can actually get the the information that you're looking at in the bottom window. Oh, sorry, I've made it go out of focus. The information that you want to see in the bottom window, but you can actually see it in context, which is quite interesting. So if you're working with like some sort of a digital signal, or you're probing some, RF transmitter, and you want to, see what signal, garage door opener or something, car key fob, and you want to see the signal, the digital signal that's getting emitted from that. Well, you can see that in context, and you can go and perform some analysis on it and look at it. What kind of voltages are you talking about? What signaling you're talking about? What's the time between the signals? And you can go and create some Arduino circuits to, emulate that. And yeah, whatever you're trying to do, you're trying to hack a key fob or something, that's a nice feature. I'm sure there's other reasons people would use this, but it basically lets you scroll through the signal, and you can kind of get a preview. It's like a mini map from a video game for your signal, which is great. I like it. Yeah, so that's your horizontal menu, and you just press this F7 button to exit out of the dual windows here. You've got markers that you can leave. You can set and clear them. Time per division, fine and coarse. Horizontal position, fine and coarse. So we'll just exit out of that menu. Is there anything that I've forgotten to show you guys? Obviously, you've got your volts per division on your y-axis here, or your y-axis, yep, which you can use there. You've got the same thing on channel 2, and then you've got your seconds per division on your horizontal axis here, so you can zoom in, and it really is quite accurate. We're looking at, we're down to 200 nanoseconds, 80 nanoseconds. You can go right in, to the signals here. So just to show you that, that's pretty much it, guys. Like I said, this is just a quick overview of some of the features, you know, some of the menus that this thing has, how it works, roughly how it's laid out. Maybe we'll see this on my channel in the future if we're doing some kind of electronics work. But really, I just wanted to create this video to share this, you know, with you guys. There will be a link in the description if you want to go and have a look and buy one yourself. I think it's fantastic. I was playing with it last night. I was probing around on an Arduino. I ended up pulling out the crystal oscillator and just connecting it up just to have a look and see, you know, what frequency it's doing, and put that in series with a small function generator, which we might do a video on next, maybe. Let me know in the comments if you want to see the function generator. There's a nice, cheap, and useful function generator, and then maybe we'll even connect them together and do some plotting, some plotting evil plans, some signal analysis from the function generator on the oscilloscope. But that's it from me. I have heard that you can hack these. You know, as far as I'm aware, all of the hardware inside of this is exactly the same between the 70 megahertz, the 100 megahertz, and the 200 megahertz versions of this, with the exception of the memory buffer. So this one doesn't have a huge memory buffer, but you can get a B model. This is the 5102P. If you get the 5102B, which does cost significantly more, it has a larger memory buffer. So that's the only thing that's different between these models is literally the memory buffer. But you can hack these with a firmware update that will let you get the 200 megahertz, still at 1 gigasample. With the same probes, and people have done that online, and you'll see videos about that everywhere. So thank you guys for watching. I hope you've enjoyed this really random, really out of the blue overview of the Hantek DSO5102P digital storage oscilloscope. Hope you enjoyed that. Take care, everyone. Stay safe during this whole pandemic stuff, and let me know what you're thinking in the comments below. Take care. Bye.